Hello again. I'm gonna continue in this video the part 2 for AP, Chem AP diagnostic test, selected multiple choice questions. Let us start with number 9. For the following reaction, identify the element being reduced and the reductant. Definitely, in order to identify, we have to know what's reduced and what is reductant. This is from electrochemistry. And the word reduced, it means gaining electrons. There are other definitions, but this is the one that I will talk about right now. Reductant, when I say reductant, also another name for it is reducing agent. Another name for it is reducing agent. It's an agent actually that makes other substances reduced, gain electron, being themselves oxidized. What's the meaning of oxidized? Oxidized means losing electron. So on the other hand, when we say oxidation or oxidized, it means losing electrons. So let us consider this equation that we are talking about. We will write it down and see which one oxidized and what is the which one oxidized, which one reduced, which one is the reductant. So the equation of our interest is carbon monoxide plus nitrogen dioxide to give carbon dioxide and nitrogen monoxide. Let me assign first of all the oxidation numbers as per the rules that we know. Carbon monoxide, the oxygen in this compound, it's not the peroxide, neither superoxide, so it is -2. Which makes the carbon +2 because the summation should equal to 0 because this is a molecule with charge 0. The oxygen also in this compound is -2. -2 times 2 is -4, which makes a nitrogen +4 because +4 minus 4 equal to 0. The oxygen here in carbon dioxide also -2, which makes the carbon +4, and the oxygen in nitrogen monoxide -2, which makes a nitrogen +2. Now let us see which one oxidized, which one reduced. The carbon, it was +2, turned to be +4. Positivity increased, it means the number of electrons decreased, it means oxidized, losing electrons. So oxidized. Nitrogen, it was +4, turned to be +2. Positivity decreased, it means more electrons are added, so this is reduced. The substance that is oxidized, we call it reducing agent because it caused the other substance, which is nitrogen dioxide, to be reduced. So carbon monoxide here in this equation is the reductant or the reducing agent. So now back to the options to choose the appropriate one. We will choose that the nitrogen reduced. So here directly I eliminate these from my option. I am left with B and C. Nitrogen reduced, while carbon monoxide is the reductant. So this will be the appropriate answer. Now we will move to number 10. If delta H is negative for a spontaneous reaction, what is true about the value of delta S? This has to do with entropy and enthalpy. And the equation that we talk about, it will help us in answering such a question, is this one. The one that is related to the free energy. So delta G equal delta H minus delta S. Delta S, it's the entropy or the amount of randomness. Delta H is the enthalpy and delta G is the free energy or the available energy. He said if delta H is negative, so this term is negative. Delta G is negative. How can I tell? Because from spontaneous reaction. so it is also negative. So we need to know what is true about the value of delta S. What is true about the value of delta S? Let me rearrange the equation. I will rearrange the equation. I can write delta G minus delta H equal negative T delta S. I multiply everything by negative, which means that delta H minus delta G equal T delta S. This is negative and this is negative. If this is negative, multiply by the negative here, it will be positive, and here negative. So it depends on the values of delta H and delta G. So delta S may be either positive or negative, because we have positive and negative. So either positive or negative. So the best answer here is that delta S can be positive or negative depending on the temperature, because as we see, the temperature is next to the entropy. So it depends on the temperature, such that the value of temperature does not make T delta S larger than delta H for the whole thing to be negative. Now we will move number 11. Lead nitrate is strongly heated, generating red-brown gas. This gas is then bubbled into water, giving an acidic solution. Which pair of unbalanced equation best describes this process? I'm not interested in balancing, but interested in the products. Again, this problem, to solve it, I have to be aware of the rules that I told you about later, this one in the table. I'm talking about moderately reactive metal with nitrate. So expected products as follows: metal nitrate to give metal oxide, nitrogen dioxide, and oxygen. So I'm expecting metal oxide and nitrogen dioxide and oxygen. So for number 11, lead nitrate, upon heating up, this is solid. As per the rule, I'm expecting lead oxide and nitrogen dioxide and oxygen gas. I'm not interested now in the balancing, regardless of the balancing. So nitrogen dioxide, from its properties, it is a reddish brown gas. It's a reddish brown gas. As we can see here, when we heat lead nitrate, reddish brown gas eliminated, which is nitrogen dioxide. This nitrogen dioxide is the gas responsible for acidic rain, because when it's mixed with water, it gives a mixture of nitric acid and nitrous acid. So this nitrogen dioxide with water gives a mixture of nitric and nitrous acid, HNO2. This is a strong acid, nitric acid, and this is a weak nitrous acid. We call it nitrous acid. So the best equation that that describes what's in the problem is part E. So the best answer here is part E. So as you see, lead nitrate decomposed to give lead oxide, nitrogen dioxide. This nitrogen dioxide, when it's mixed with water, it gives mixtures of nitric acid and nitrous acid. Why we write it in ionic form? Because the nitric acid is strong, it dissociates completely into ions. Now we will move into number 12. In number 12, how many physically distinct isomers of dichloropropane are possible? When we talk about isomers, we have a lot of types of isomers. Constitutional stereoisomers, as you can see here, configurational, conformational, and each one configurational may be geometric, optical, and the optical itself may be enantiomer or diastomers. And I've written for you here some definitions, and you can look also for definitions of for isomers. The best thing which is important about the isomer is that each of two or more compounds with the same formula, they are with the same formula but different arrangement. So this will help me in choosing the appropriate answer. So I have dichloropropane. Let me draw it. 1, 2, 3. I can draw it like this. The rest are hydrogen. This is the first compound I can draw. I will choose, according to IUPAC, the longest continuous chain of carbon chain, and then I will start numbering such that to give the halogens the lowest number. So this is 1, 1 on position 1. We have 1, 1 dichloropropane. This is the first compound I can talk about. Second compound that I can draw also, chlorine, carbon. I can put one chlorine here and other chlorine there. And again, this is the longest continuous chain. I will number it 1, 2, 3. So on position 1 and 2 we have chlorine. So it's 1, 2 dichloropropane. Another compound still I can draw, another isomer. All of them, they have the same molecular formula but differ in structural formula. Carbon. One chlorine here, one chlorine there. Again, according to the IUPAC, this is the longest continuous chain. I will number it, and it's 1, 3 dichloropropane. As you see, all of them, they have the same molecular formula but different structural formulas, which make them having different properties. So number 4, I can put chlorine and both carbon in the second position. This will be hydrogen rest. And I will choose the longest continuous chain. 1, 2, 3. So on position 2, repeated 2 times dichloropropane. So these are the 4 isomers that I can talk about, and the best answer for it is part B, which is 4 isomers. Now let us move to number 13, an aqueous solution, a 0.1 aqueous solution of an unknown white crystalline substance. So unknown white crystalline substance shows a precipitate when treated with silver nitrate and turns phenolphthalein into pink. Phenolphthalein is an indicator, as you know, and this indicator is colorless in acidic medium while it is pink in basic medium, as you can see here in this figure. pH less than 7, so the indicator here, it's in the conical flask, it's colorless, as you can see. At the end point it turns into pink, and this is intense pink. This is overshot of the substance that it is added to phenolphthalein that makes the solution basic a lot. So phenolphthalein, it is colorless in acidic medium while it is pink in basic medium. As you see here in number 13, it makes a precipitate when treated with silver nitrate. So this will help me in solving the problem quickly. NH4Cl plus AgNO3. This gives me AgCl. I'm not gonna continue the rest of the equation. This is the solid of my interest. So okay, this might be an option, might be. For part B, this is part A. For part B, I have K3PO4 potassium phosphate, AgNO3. Also, I got Ag3PO4, which is a precipitate from the solubility rule. We should be aware of the solubility rule. For part C, KNO3, AgNO3 and KNO3, no reaction, so no precipitate. no reaction, no precipitate. So part C I will eliminate from my option. Part D, I have AgNO3 plus NaCl, AgCl. Okay, this is a precipitate. And part E, which is ammonium perchlorate, plus AgNO3, it gives me perchlorate, it gives me AgClO4. This is not precipitate, so I will eliminate. So I'm eliminating. I'm left with AgCl, so I'm left with this option, and this option. The AgCl, it's not basic, so the only option that I'm left with is potassium phosphate. So the option I'm left with is potassium phosphate, and we can prove it actually quickly if we want to prove. Potassium phosphate, when added, as we said, to AgNO3 to give me the silver phosphate. The silver phosphate is basic in nature. The Ag has no affinity to water, Ag plus, no affinity to water. I will take the phosphate ion and put it in water and apply Bronsted and L'Oreal. H plus will migrate to the phosphate ion to be left with HPO4 2 minus and OH minus, and as you see, it's basic in color, that's why it turns pink. Now we will move to number 14. This is about radioactivity. Radionuclides such as americium, which emit non-penetrating radiation. Non-penetrating radiation are less dangerous with respect to external exposure than radionuclides such as cobalt, which emit penetrating radiation, which is the non-penetrating type. The most common basic radioactive radiation types: alpha, beta, and gamma and X-rays. These are the most common. Alpha, this is the helium. Beta, like an electron. And gamma rays, which is gamma rays, as you can see here from the figure, it's the most penetrable radiation. The beta, it penetrates, but not like gamma, but the least one that stops on the paper or the skin is the alpha. So it interacts a lot with the matter around it. That's why it's not highly penetrable or non-penetrable. So the best answer for such a question is alpha particle. Now, which of the following solutions would have a boiling point? Which of the following aqueous solution would have a boiling point most similar to that of 0.2 molar solution of sucrose? This has to do with colligative properties. To solve this problem, we have to be aware of colligative properties. Colligative properties are characteristics of a solution that depend on the ratio of number of solute particles to solvent particles. From the colligative properties: freezing point, depression; boiling point, elevation; osmotic pressure; vapor pressure, lowering. These are the colligative properties in a solution. We are interested in boiling point elevation. Let us write the formula that we know and we learned in number 15. Delta T equal I, which is a number of ions, times the constant molar boiling constant times the molality. Okay, here the given 0.2 molar of sucrose. As you know, sucrose is a molecule, which means the Van 't Hoff factor I, number of ions, equal to 1. So Kb is constant because it's in a solution of water. So let me compare the rest. NH4Cl, let us start. NH4Cl, it's ionic and its I is 2. If I multiply by 0.2 concentration, 0.4. Okay, the original one 0.2, the original 0.2 times 1 for the sucrose 0.2. So I need to look for substances that they give me 0.2. So A is not an option. We will continue. B, K3PO4, 3 potassium and 1 phosphate, so I is 4. I is 4 times 0.1, which is 0.4, not an option. I want to like similar to 0.2. Acetic acid is a weak acid, which makes it molecule I is equal to 1. So 0.1 times 1, 0.1, not an option. NaCl ionic, NaCl 2 ions, so it is 2 times 0.4, 0.8, not an option. Left with E, lithium perchlorate, lithium 1 with chlorate 1, so I equal 2 times 0.1, which is 0.2. This one similar to 0.2 molar of sucrose, so the best answer and the correct answer is E. Number 16, which reagent is most likely to affect the following transformation? In order to think of such a problem, I have to look at the equation that he has given to me. The equation is that 3, this I'm dealing with number 16, 3i minus to give plus what? المهم to give what's important, I3 minus. Let me check their oxidation number to see what happened. I minus is monoatomic ion, so the oxidation number is -1. I will assume I here is x, 3 times x, 3x all equal to the total charge of the ion -1, which makes x equal -1 over 3. The charge, the oxidation numbers, it was -1 turned to be -1 over 3, which means losing of negativity. So what happened is that oxidation took place. So oxidation took place. So here we need an oxidizing agent to oxidize I minus. So we need an oxidizing agent. Let us check. We have potassium permanganate. Potassium permanganate, this is the potassium permanganate. It's purple in color and it is a strong oxidizing agent actually. Strong oxidizing agent. H2S, it's a reducing agent. It's not oxidizing agent. Potassium thiosulfate, also reducing agent. Nitrate, it's not strong oxidizing agent. Not strong oxidizing agent. So I'm left with the strong oxidizing agent that oxidized the iodide into I3 minus, which is potassium permanganate, and this is the best answer. Thank you, and inshallah I'm gonna meet you in the following video, part 3. Thank you.